Welcome back, everyone. To introduce our second presenter of the morning is Chris Blunt. Chris has attended his first COSAC, I think, in 2013. Very quickly became clear that Chris believed in the COSAC ethos of saying what needs to be said. And some of your comments on LinkedIn would endorse that you understand that. So Chris has been a great COSAC stalwart and supporter ever since then, also presenting COSAC APAC on all three occasions. Recently moved from New Zealand to Northern Ireland. Can't imagine why anyone would want to do that, Chris. But I'm going to hand over the stage to Chris Blunt. Chris, take us through your SABSA to Architect Zero Trust Networks, if you would. Thanks very much.
Thanks, David. So I've got my own title slide as well, so redundant. I'm just going to skip beyond that. But we are talking about using SABSA to architect zero trust networks. This is going to be largely based on work that I've done in my previous life living in New Zealand. So real world example, if you like. A little bit about me. As David said, I've recently moved here to Northern Ireland from Wellington in New Zealand, where I was the Chief Strategy Officer for a cybersecurity consultancy that I owned there. I've been using SABSA since about 2009 in delivery of architecture work that I've done for customers. You can see 27 years of experience, master's degree, SABSA Masters, probably the most pertinent thing here, member of the board of SABSA Institute. And I mark advanced papers, so if you get harsh criticism on your papers, it's probably from me. I'm sorry. So what is zero trust? I'm afraid I can't see any of you, so normally these are quite interactive sessions when I run them. I normally get people shouting out what they think it is, but I've got a couple of definitions that are pretty much seen as the industry standards, if you like. So first up is from Forrester, from their No More Chewy Centers, or the M&M models, as Lisa Lorenzen would say. So in zero trust, all network traffic is untrusted. This means that security professionals must ensure that all resources are accessed securely regardless of the location, adopt a least privilege strategy, strictly enforce access control, and inspect all and log all traffic. Now that last bit is actually quite difficult, the inspect and log all traffic, when you're actually making sure that you don't trust the network, because you generally have to encrypt everything on the network if you don't trust it. So some gotchas in some of these definitions, in my experience. The second one is from Zero Trust Networks, which is a book by Doug Barth and Evan Gilman. And it says the assumption is that the system and traffic within the data center can be implicitly trusted is flawed. I think we can all agree that's true. Modern networks and usage patterns are no longer echo those that made the perimeter defense make sense many years ago. As a result, moving freely into a secure infrastructure is frequently trivial once a single host or link has been compromised. And this is what we see time and time again in environments where attackers gain a foothold into one environment and then use it to move throughout the environment, traversing through the security controls that exist within it. Interesting that we're talking about perimeters here as well. So their view is that the perimeter is dead, which I think echoes a lot of sentiments, particularly with the adoption of cloud services. So Fox Mulder said, trust no one, but zero trust isn't really about trusting no one. It's about doing away with our 1990s approach to security and starting to think about how things can be done more effectively and efficiently. It's about thinking about what trust is and what we can do to actually gain that trust, that what we're accepting as traffic from a location is actually what we should be accepting, rather than just implicitly accepting everything that comes towards us. So Ronald Reagan said, trust but verify, or if you're a fan of Chernobyl, it's an old Soviet proverb. So this means that we should strongly authenticate users using things like two-factor authentication, one-time passwords, MFA, whatever you want to call it, to ensure that they are the person that they claim to be, or they are the individual they claim to be. Or if it's a machine, using certificates that are being issued and can be managed. so that you're sure that the endpoint entity is who it claims to be. Now, then we have the next part of it, which is where they're coming from. So if you can't trust a network to be where they're coming from, what can you trust? So this is where we start looking at things like device authorization. So you start looking at whether a device is compliant with your set of rules, whether it's your device in the first place, etc., and then allowing it to access based on those two factors. But essentially it means not accepting unauthenticated or unauthorized sources to send you traffic. So this next section is really about some examples. So possibly the most famous example would be the Google Beyond Corp. So this is a logical view that I redrew from a Google drawing to show how they look at it. So you can see within here, they have users that are on public networks, and they have users within Google buildings, which they treat as unprivileged networks. So essentially almost the same as a public network. The only real difference between these authorization and authentication mechanisms is that the managed devices within the unprivileged network within the Google buildings allows a slightly more straightforward access based on the 802.1x protocol through the radius service. So the basics are users are not on the corporate network. Apps are invisible, so they cannot see them. They're not exposed to the internet. You have to access them via the access proxies that are there. They use the internet as a secure network without VPN, and app segmentation without network segmentation. So they're basically only allowing you to access the systems and services based on what you're actually authorized to do, and what you're actually authorized to do and access can be different depending on whether you're on a Google device or whether you're on a Google network within a building. So you may have access to a higher number of applications, for example, if you're in an unprivileged network within a Google building versus when you're on a public network. So this model is one of the most common, and it's the one that I'm going to be talking about in a little while. It's the most commonly adopted model because it's probably the easiest to implement for a number of reasons, as we'll see in a minute. The name Beyond Corp is Google owned. So a number of vendors are using the terms secure access, secure edge, so SASE. Or if you want to be really generic in your environment, you could probably go along with a zero trust network access model for this particular view. So PagerDuty in the book that I mentioned earlier by Evan Gilman and Doug Barth on zero trust networks have a slightly different model. So here the concept is about embracing variable trust, and it enables you to create fewer policies while maintaining the same amount of access. So here we've got trust data sources. So we've got user data, device data, activity data, feeding into a trust engine, which then has a set of policies and rules applied to it to gain authorization. And then in the bottom right-hand side, we can see a client goes to access a service, the control plane intercepts that, the service checks that they're allowed to access based on those rules, reconfigures the service, gives them an access token, which is ephemeral, so it's only for that use. And then the client can directly access the service using that. So it's a much more complicated view of setting it up, but it gives you the ability to create what are essentially micro architectures within your environment. You segment up your environment based on your authorization and authentication policies. I haven't actually done this one, so yeah, and it always goes down the path of a bit of a debate with the network teams on what's possible and what's not. But as we move down to the path of software-defined networking being more and more prevalent, I think it will become more and more common to create these microarchitectures, and the same with cloud adoption. So as we're using more and more cloud technologies like AWS and the like, I think we'll see micro-segmentation and policy engines becoming the norm. So this is a case study. I've had to sanitize it heavily because I no longer work for the organization that I created it under. So it should still be of value, I believe. I've managed to retain the pertinent points as they relate to SABSA and its application to zero trust networks, or the zero trust network access model, I should say. So customer was a new entity. They basically spun out of another organization. Their legacy environment was being maintained and managed by the organization that they came out of, with a view for it to be transformed and moved into cloud services. So when they set up their strategy, the principles here guided their strategy for cloud, where they were going to go with their entire IT infrastructure. No surprise, they went cloud first, so they didn't want to build or own anything. IT meant that they wanted to own as few assets as possible, so they wanted everything as a service as they possibly could. That included their laptops and end user devices, which was effectively down to the point of they were delivered, configured, and managed by a service provider for them. Borderless, they wanted to be able to break down the channels between the internal staff and the wider sector, both a business to business point of view and a business to user point of view or customer point of view. They wanted everything to be secure and protected because they were dealing with highly sensitive information. So they wanted to make sure that even though they were using the cloud and they were using these models, nothing could be accessed unless it was allowed to be accessed. They wanted it to be agile and enabling, so they wanted everyone to be able to work in better ways than they possibly could in the past, reducing the complexity and simplifying the interaction between staff and their experience with IT in general. And they wanted green IT, so obviously one of the benefits that they would have had from not running their own data center or hosting it in a sort of traditional data center is that they could gain some of the sustainability view that they would have from using the cloud. So from this, I took those. Oh, sorry, I should mention they also had 4 objectives that they wanted to get from this as well. One was that from a connect point of view, they wanted their users to be able to connect to the system anytime, any place, anywhere, or if you're as old as I am, the Martini approach to access. They wanted to be able to allow their users to create from anywhere, and access business data from anywhere. We wanted them to be able to communicate both inside the organization and outside the organization so that they could collaborate and work and share ideas and information securely. So from this, I managed to develop a set of business drivers, and this is the subset that's pertinent to zero trust network architecture from a network access point of view. So we've got BD4, which is ensure that information is protected against accidental, deliberate, and malicious unauthorized access, disclosure, and misuse. So that's a fairly standard one. I'd be surprised if we all sat down and wrote an attribute if that one wasn't in there. BD8, users that are only granted access to information and functionality that they are authorized to have based on their role, the device they are using, and other relevant contextual information. So this one is very specific. It's fairly similar to ones that you would probably have created in your past, apart from the fact that I've thrown in this contextual part here. So the device and other contextual information may not have been there from the access point of view. And then BD22, the security of the organization's information services and the information they store, process, and transmit should not be reliant on the use of the corporate network. So I had to explicitly create this one after we went through the first round of business drivers, because everyone was like, well, contextual information can include the network. We can use IP addressing to make sure that we're only allowing people that we know to access. We can use locations such as New Zealand to make those decisions. And while that was true in the past, it's not really true in a zero trust environment, because in a zero trust environment, the network shouldn't form part of your decision to allow access or not. So IP address ranges or IP addressing is a really bad way of trying to identify who's accessed, because it's not actually a person, it's a machine, and that machine can be substituted for other machines, obviously. So that took a bit of debate, but finally it was accepted by the business and senior IT management as being a valid business driver for their organization. So I'm assuming that everyone's reasonably familiar with multi-tiered attribute profiling, but if not, I've shown how I've broken those down. So this is the first one, the ensure it's protected against accidental, deliberate, malicious, unauthorized access and disclosure and misuse, obviously. And you can see here I've broken that down into authorized and protected, and then at the bottom I've broken authorized down into identified, authenticated, and access controlled, and then protected into access controlled, confidential, and private. Now, I'm going to add a massive caveat here. When you're doing multi-tiered attribute profiling, your view of how something may break down into its component parts as you decompose a business driver may be different to mine. So yes, there probably could be some additional or removal of some of these attributes from here, but this is the view that I came up with and used for the creation of the architecture here. So I'm going to slow down my talking for a second. I'm going to run out of slides in a minute. So BD8, which was the ensure users are only granted access to information and functionality that they use and are authorized to have based on their role and the device they're using and other relevant contextual information. So you can see that went down to authorized rather than authenticated. And then we've got access control and authenticated, context-based because we literally mentioned it. So this is a new attribute that I created. Identified, which is one of my standard set, and then role-based as well. So role-based has been added when we compare it to the previous slides. I'm just going to roll back so you can see that. So role-based wasn't there before on authorized. But the description and definition of this business driver added in both context-based and role-based to the authorized business attribute. So BD22, which was the not using the corporate network or shouldn't reliant on the corporate network, has been broken down into authorized as well. As you can see, we've still got access controlled and authenticated. We've still got context-based and identified. So this is like a subset again of the previous one. But the context-based one is really important here because this is where we start to flesh out what that means in some detail. So the relevant attributes then, I'm not going to run through all of these. I'll pick out the pertinent ones. But obviously we want everything to be access controlled. And we can see here we're saying access controlled is access to information and functionality within the service must be controlled in accordance with the authorized privileges of the user requesting the access. And then A11, authenticated, all users accessing a service must be subject to the procedure that verifies that they are the owner of the claimed identity. So these are fairly standard attributes in my experience. I've stripped the measurements and metrics from these attributes, by the way, because they're relevant to the organization, but they're not relevant. They may not be relevant in any other environment. So A12, authorized, all access to the information held in the service must be authorized by the business owner of the service. So that's the initial authorization. Obviously, that doesn't mean every time a user accesses. It means when a user is set up and they're granted privileges based on their role. It's the roles that are granted access based on that, and it's normally the business, or it should be the business owner of the service that's approved that access to their information. So context-based is our new attribute here, and I've defined it as the decision to authorize access to information and functionality within a service should take into consideration context of access attempts, or the context of the access attempt, e.g. authentication method, geographic location, time of day, and status of the device. So geographic location is an interesting one because it can have some interesting problems that are associated with it, especially in the age of IP4 network blocks being run out. And the reason for that is we're starting to see where ISPs are trading, or companies are trading their IP4 segments, but they don't change the country that they're registered in. So, you know, for example, you could end up with a block being used in the US, which may be a desirable geographic location for your users to be able to access from, that have been sold from ISP in Russia or China or somewhere else, so it's less desirable for your organization. And you wouldn't be able to detect that because it's where the block is registered, not where the block is in use. So when identified, I think it's pretty straightforward. All users and objects must be uniquely identified to ensure that users can be held accountable for their actions they perform. And role-based. Access to information within a service must be based on roles that grant only permissions and functionality required to perform that role. Note, this includes all privileged admin and non-user accounts. So non-user accounts are service accounts in this description. If you're not managing those, then you've probably got some challenges in your environment already. So then I use these attributes to look at what services would be required to deliver them. And this is a table that represents, actually, you see access control requires an authorization service, an access control service, mobile device management, and account management. So account management here, I know from the numbering that I've got there, that account management is a service management activity that's wrapped around those other things. So authenticated requires an authentication service, a directory service, a certificate service, mobile device management, and then authorized requires account management. So that's what I was saying earlier about putting people into the right groups, making sure that they're actually authorized to go into those groups, etc. Now, every time I present this COSAC, or in the past, I get asked a lot of questions around why do I separate out things like authorization and authentication and directory when Active Directory delivers all of those things. And it's important to map them out separately, because that may have been true in the past, but as you move towards cloud adoption, and particularly when you're in hybrid mode or you're using multiple clouds, then your authentication services may be different across those clouds. But your authorization services will certainly be different across those clouds typically. So you need to map them out to make sure that it's the same service that you're talking about, and it's the same tools and products that you're using to deliver them. Because it could be multiple tools and products in your environment that are delivering those things. And you need to work out whether or not they can all do the things that you need them to do. So context-based requires an authorization service, certificate management, and mobile device management. The mobile device management is probably the most important one there for most organizations doing the zero trust network access model, because it's the engine that you use to gain assurance that the device is in a known state. So whether you're using Intune or one of the competing products such as AirWatch or whatever it's called nowadays. Can't remember what they've renamed it to. You have to be aware of the state of your device. So then we've got identified. So obviously to be identified, you've got to be authenticated, but to be able to authenticate someone, you probably have to have them enrolled in some manner in directory service, or you might have issued certificates for the device or the individual themselves. And then role-based, you've got authorization service, access control, and account management again. So I then modeled out each of these services, and I've just turned them into these diagrams for ease of use. And I'm only going to show two of these, which is the authentication service and the authorization service. So the authentication service was defined at the top. So the logical layer is appropriately authenticate entities claiming an identity before they are granted access to the service and the information they hold. So that may be a username and password in some environments, or it may be multi-factor. But if you can see here, so multi-factor could actually at the lower level have multiple ways of doing that. So it could be a token, software token, hardware token. It could be a digital certificate. You know, just multiple ways of doing that, including similar with the identity protection. The identity protection could be the risk-based policy and thresholds, which could be things like, has this user suddenly logged in at 3 o'clock in the morning when I've never seen them log in before at 3 o'clock in the morning? So, you know, there's so many different ways you can look at that. And the way that those rules normally apply is defined by either the software or the organization. And you have to be really careful about how you structure them and construct them, because if you don't structure them correctly, you can end up in a situation where a rule triggers earlier than it intended to and bypasses a rule that you really care would trigger. I've seen that happen a few times now. So the second one is the authorization service. So this was, the logical layer was defined as grant entities access to only the information and functionality that they are authorized to have access to based on their role. And you can see here, we've got things like conditional access, and then we've got the conditional access policies that are applying. So this is a very, very high level view, obviously. So now let's have a look at the conceptual view that I created for the organization. So this is a slightly simplified view. I have to say, this is pretty much what I presented to them in a architecture document and set of presentations in 2017. And they bought into it big time, based on this diagram and some of the slides that we've previously seen. So here you can see basically what I've defined is in the cloud service, there's a mobile device management service, there's a certificate authority, and there's an identity and access management service of some description. Users and devices hit the IDAM service. The device is constantly being polled at regular intervals rather, for them to be able to access cloud applications. When they access the cloud applications, the authentication and authorization is played back to the IDAM service, which verifies that they're able to access the service. On the legacy side of things, it's included for completeness, but you can see that there's a traditional remote access service to give them access. So that's a Citrix access gateway, in effect, to give them access to those other services that are waiting to be transformed and moved to the cloud. So this is what the logical architecture I then developed based on that once I had approval to go ahead. And here you can see the MDM and the IDAM service has been split out. The MDM is using configuration management and playing that against a compliance engine. And it's also got the certificate authority, which is storing in the directory service of the IDAM. The authorization service is checking against the configuration management, which in turn is checking for compliance. And at regular intervals. I think the interval was 30 minutes once the service went live. And the authentication service is obviously checking against the directory service, the authorization service, and anything else to make sure that the token that it's been provided with is allowing access to the cloud applications. So you can also see in this model, the remote access service was actually moved out and had to be run and managed as a managed service by a local service provider to get access into the legacy environment. So can you guess what service provider we're about to use based on this diagram? Yeah, it's Microsoft. So here we can see everything is really down to that physical layer. In the cloud, I haven't put in any architecture around the firewalls, etc., because it's not ours to manage. They're still part of the service, but we have no control over. All we know is what are the components that we're using within the environment. So here you can see in Intune, which was the MDM solution. We've got compliance management, the configuration management, and cert authority as before. And then Azure AD, we've got conditional access is the actual service for authorization. We've got authentication, and we've got directory service. And it works in exactly the same way. Over the other side, you can see the coexistence environment becomes slightly more complex at the physical layer with a remote access gateway and the virtual apps and desktops. And this is still a simplified view of that because there were other components in there. But essentially, this went live a year and a half ago, and it works exceptionally well. The users were able to access from anywhere. If we had a device that went out of compliance, they weren't able to access and download any additional information onto the device, but they could access in a bubble within things like Office 365. So they were able to get in and just use web-based apps, but they couldn't download anything further until the device was made compliant. So it was really, really intuitive and easy to use, especially for a workforce that was perhaps on the slightly older side, less intuitive with technology. They weren't IT users. They were basically social workers. So it worked exceptionally well. It enabled them to access information anywhere in the field, which they previously couldn't. So I think it transformed the way that they worked. And obviously in the COVID-19 stage, this was an organization that had to do little to nothing to make things work once they were in lockdown. So yeah, the model just is very intuitive. So there were some challenges though. The end users asked a number of questions. That's why do I have to enter a one-time password every time I'm on the corporate network and when I'm outside of the corporate network? And the simple answer is because consistency. So this started off as a problem where people were asking, why do I have to do this? Why do I have to do this? And rapidly they realized that it came down to the consistency and ease of use. If they did it every time they had to access or authenticate, or their session had timed out, then it became second nature for them. They didn't have to worry about it being different, which is what was happening in their previous roles and organizations, and with the previous solution that they had when they were part of the other organization. So the other question that they had was, like, why can't I access a service from my home computer like I did before? Well, initially we started with the model of you can't access from anything other than a device that's issued. And then we dialed that back to you can access, but you can't download or store anything on the device if it's not a device that's been issued by the organization. So I think once they were able to at least read and respond to emails in their personal time at home, a lot of them felt a lot more comfortable. Well, although why you'd want to do that is beyond me. And then the IT employees, which is probably where we've got the most problem, because other systems and services were being bought, transformed, etc. Within the organization, we came up with a number of sticking points. So I've bought a service that requires Kerberos or LDAP connection. Well, based on the choices we made with going wholly native cloud, guess what? That's not possible. The only way it was possible was if they were being deployed into Azure, and most of the applications weren't at that point in time. They were being deployed into AWS. So that required re-architecture of those applications so that they were using modern authentication mechanisms, which had to happen at some point anyway. I think it just accelerated the transfer. And then IP addresses, I think I've already covered this. I need an IP address to restrict access to users on the corporate network. Well, when the corporate network is the internet, using IP addresses is not possible, I'm afraid. So that's a challenge that, and a mindset that has to be overcome. It took a long time to get the other architects and the engineers to accept that IP addressing wasn't the way to secure things any longer. So, right, I think I've talked too fast because I've ran out of material. So these are some references. I will make sure that the slide deck is available from COSAC Connect team. So no need to rush to write any of this down. But we're into Q&A already.
Thank you very much, Chris. That simply comes from being an experienced COSAC presenter who's expecting 5 million interruptions during the course of your slide deck.
Yeah.
However, we do have quite a number of questions and challenges lined up for you.
Okay.
Before we get there, the poll that was posted during your presentation, give you the results. If you want to click, everybody else wants to click on the poll window, you can see it for yourself. Does your organization plan to adopt zero trust network access? 7%, only 7% say it's already in place. 18% say the projects are underway. 37% are planned, and 37% have no plans at all. Given that you might be led to think that now is the time for zero trust, any comments to make on the results of that poll?
Yeah, I think it's probably the typical problem, isn't it? When there are new ways of doing things, they take a long time to filter into the reality, because people still cling, for want of a better word, to what they know. So I think although now would be a grand time to be moving towards zero trust network access, I think it's very difficult in a time where people aren't in the office, aren't able to work, to move these types of projects forward quickly and easily, to make those transitions and changes.
Okay, thank you very much for that. First question is a no-stage question from Dmitry. I can't read that this far. Klebnikov, sorry, Dmitry. Given that ICT systems live in a virtual world, while human beings belong to the real world, there's always a proxy between those two worlds, for example, a terminal. Therefore, one could argue that zero trust network cannot be achieved until we find a way to maintain the chain of trust that binds the individual to the virtual world. You want to discuss this?
Wow, that's more like a physics question than a question to be posed to me. I think for me, I think there are two real important tenets of zero trust. One is it's about making sure users can access the data that they need, and that access is based on strong authorization along with strong authentication. But from the architecture of systems and services, it's really about making sure the network isn't considered as part of the security model of those systems. I did have some extra slides that I didn't put in because I didn't think I had enough time, because my previous attempts to get through them had run out, where I've modeled trust, you know, the SABSA mechanism for modeling trust. Where you say what each party wants, and then you break down and deconstruct using attributes. And I think that's an important viewpoint that I wish I had put in, because it would have been a clearer discussion.
We have time for it, Chris.
I don't have them at hand because they're on a different machine. The thing here would be like not modeling your network as part of your trust is very difficult for people that have previously designed information systems based on the network being absolutely rooted in their trust model. Yep. So if probably the best way to look at it is, if I look at this, just a second, if you look at this type of diagram here, you can see I'm showing the flows between the different components and the connections between them. So whether they're implicit or explicit connections, but at no point have I decided that the network there can be trusted. So the network between compliance management and configuration management, if that was being built in my data center, for example, I wouldn't trust it. I would authenticate the two endpoints myself. You know, I would make sure that they authenticate with each other before they're authorized to send information backwards and forwards, so mutual TLS, for example. And I would make sure that the information that they were sending between each other was encrypted.
Yep.
So that's how I think that's how you handle it. Like I said, that's the PagerDuty model, right? It really flows back to that, and their approach is certainly all the way down to that, but it's very, very difficult to do without big bang replacing an entire architecture. So piecemealing it doesn't really work. So you have to be able to get into this idea that I've got this system service and I've ran it for 15 years, for example. Now I want to move it somewhere else and I want to make it different. It's true digital transformation, and it takes a lot of time and a lot of planning.
Well, there was a lot of discussion in the chat window while you were speaking that referred to the slides you don't have with you, or in essence, those slides about trust modeling and domain modeling. The ability to define the boundary between any domain at any level and its interaction with every other domain, whether that is machines and humans or networks. And what does trust really mean in the interaction between those domains? What controls have to be in place to give me sufficient trust to allow those domains to interact?
Absolutely.
While you were talking, posted a note. I'm so bad with that, with questions. It seems that Chris missed the point of the boundary I was talking about. But is that what you meant by the boundary? The boundary between domains of people and systems can be defined as SABSA domains, and the trust between them can be defined?
Absolutely, and that boundary can be as wide or as small as your organization wants it to be, right? It's really about what works in your organization. So you can see if in the diagram that's on the screen at the moment, the MDM boundary is a boundary, right? But I could shrink that boundary down to the compliance management boundary and say that individual service is its own boundary within the service. And you can keep going with that until you've broken everything up into the smallest pieces you possibly can. But there is a point of diminishing return on that, right? And the amount of effort that you have to put into it may be excruciating. It's really about what's acceptable and what point that's enough, if you know what I mean. And to go to your question, modeling out what's required to give you that trust, again, is down to the individual organization. And so some people seem to be happy to post everything on the internet as if it's not a problem at all. Other people want to lock it all down and make it so you can only access it if you can get through a gateway. And that's fine. It's really down to what each individual organization wants. Yeah.
Okay,
just Lisa's comment there, boundaries all the way down.
That's great. As you can see, chief mischief maker among the chat stream was the brilliant Lisa Lorenzen. So we've promoted Lisa straight onto the stage to cause some havoc with you. Over to you, Lisa.
Oh dear. Can you hear me?
Yeah.
Great. So Chris, one of the biggest challenges that I've run into working on zero trust projects is the expectation gap, the desire when you go into a project versus what's actually feasible to accomplish. And it seems like applying these SABSA principles helps to maybe set expectations more accurately for the project and for how the phases will unfold. But I'm wondering, what did you learn, by the end that you didn't anticipate in the beginning?
I think the biggest thing for me was that when you think you've won somebody over, make double sure that you've won them over, because what I found is that the end users don't care, right? As long as it's easy to use and you can explain to them why it's easy to use, they will largely lap it up. Where I came slightly unstuck was where the other architects. So this slide here really, I could have carried on with the IT employee architects forever, right? It's like they would have just kept going with problems forever. But I thought I had buy-in from them. They've gone through all of the the architecture review boards, been approved, senior management have bought into it, etc. And it wasn't the top level that was the problem. It was the next level down. It's the other influencers in the organization that wanted to influence in their way and suddenly decided that my way was going to prevent them from doing their way, which was kind of challenging. And I'm not one for shine away from an argument. I think we're all agree on that. So yeah, it created some tense moments where we had to just like constantly revalidate the point all the time.
Layer 8 is always the hardest part on some of these projects.
Yeah, and I think you probably would have seen this as well. It's like they start with one thing in mind, and this is the way we're going to do it, and then suddenly they've got another service that they bought that they want to incorporate into it, and it doesn't take into account the requirements. So the person that's gone out and bought it doesn't have it. It's like, well, it's got LDAP, just make LDAP available. It's like, what, on the internet? I don't think so. You know. So yeah, we kept going around in these circles to get to the point where we've gone over it 5 or 6 times and to move forward. Interesting enough, I've had a discussion recently where we were talking about zero trust network access as a model, but that kind of got lost in the conversation because everyone defaulted to just talking about zero trust, and then the network team jumped in and we're like, you can't do zero trust. There's no way we can get to zero trust. You know, our data center isn't currently architected to enable us to get to that point. And it's like, then I had to dial it all the way back in the conversation. It's like, no, that's not what we're talking about. And now we have to be really specific about what language we're using.
Right, absolutely. Zero trust, it means so many different things to so many different people. You almost need to start every conversation with a level set and or stop using that term entirely. Yeah,
I mean, the SASE is a quite useful term. But some people in the organization felt it was a bit too vendory. And I said, well, it's not, it's just a connotation of zero trust. So they wanted to go down the network access model. So I've accepted that that's the language we're using. The network teams accepted that's the language we're using. And therefore, at least we're using a common viewpoint and a common language. And I think that's the challenge that we have with all architectural projects, probably all pieces of work we ever do, right? Is that, are we all talking the same language?
Absolutely.
We're all getting a nice tour of Rob's house here.
Sorry, the dog's aiming to bark and look out the window and chase bad people away. So I'm trying to get him out of the room, but it's not working.
Rob, just before we get to you, thank you very much, Lisa. We've a number of very popular questions with a no stage request, Rob. So can you just hold on there for sure. Just a moment? Top of the list, Chris, is actually from Yako. The $1 million question. How do we simplify this as security architects? We already have most people screaming at us that we're overcomplicating everything. This seems to be one of those things that we are overcomplicating, making the rest less likely to want to adopt any of this. Any observations?
I think that goes back to the conversation I just had on the questions we just had from Lisa. It's all about communication and collaboration. It's like you can't. So my project here weren't done in isolation. I worked with the engineers that were going to be responsible for implementing them, and I stepped through what the plan was, what they were going to have to do, etc., to get them to buy into it. I mean, the thing here is with the zero trust models, no matter which one you're doing, the network access or the more fully formed, get everything down to a microservice level and isolate it from everything else that it's in the environment with, so they can't talk to each other without there being explicit allowance. They're not easy to implement, but once they're implemented, they're actually easier to manage because they're actually more simple to manage because you know what your trust model looks like. It's implicit in your environment. You've defined it up front, and I think it's actually a better way of working in the long term. I mean, there are definitely challenges. Let's put it that way. There are definitely challenges, particularly with the sort of PagerDuty model, because nobody wants to, in my experience, say these 3 boxes that all do the same thing in this zone shouldn't be able to talk to each other, even though they shouldn't be able to talk to each other, because it's only upstream and downstream communication that should be allowed. But the reality is that's what should happen. So there should be segmentation within zones, right? but people don't want to do it. So yeah, it's complex. It's complex, but you get better security out of it.
Okay, thanks very much, Chris. We'll go to Rob, and then I'll come back to Alex Parkinson as a no-stage question. So over to you first, Rob.
Yeah, I think I know the answer already, and I'm thinking it's going to be a very quick answer. But if you look at what we've got today, we've got a lot of kind of front door access with regards to zero trust. You know, are you allowed, yes or no, to that service? But you know, kind of off the back of Gordon Jenkins' presentation last year's COSAC, is the concept of using that conditional access and that contextual-based trust to authorize or step up access to a service based upon that level of trust. So, i.e., you can view your balance if you've got, we don't trust you very much, but you can transfer some money if you have that step up. So what I'm wondering is, have you come across any kind of next evolution to that sort of kind of functionality in that contextual based trust within authorization?
Yeah, so the what you're describing there is exactly what happened here. We went down the path of using the Intune service, which can, just in case you don't know, which can now be replaced. So Microsoft allow you to now plug in third-party MDM platforms into Intune to do this as well. So you can use, I still don't know the name of it, the AirWatch, for example, or whatever it's called now, as your MDM, but have Intune make the decisions based on the information coming from AirWatch. The thing here is, for the zero trust access model, that really is the model. It's the user strongly authenticates. So username, password, one-time password. I think pretty soon we're going to see services start to drop the password and just go with the one-time password. Why are we entering multiple passwords? They don't really add any value. And then the authorization side of it, which is coming from the contextual-based information. So that can be as basic as you like. Is it a machine that's enrolled in the domain, or is it domain joined? And does it have a certificate issue to it, as an example, all the way up to I've set a load of requirements that need to be met from the configuration point of view. Are they true? Is it got the latest operating system on it? Is it patched and up to date, etc.? And make a decision based on that. To the risk-based decisions, which normally come in at the bottom of the rule base. So you know, the whole thing around, all right, am I logging in at my usual time, or is this unusual behavior? Am I suddenly accessing from China when I was in New Zealand last night? Is this a journey that could have happened, type stuff? So yeah, I mean, ultimately, I think I'm not seeing it changing. I'm not seeing it shifting. I think what we're going to start to see is the amount of granularity in the rule base will improve.
Yeah.
And the way that we do that contextual stuff will improve. And the options for doing it. Cool.
Thank you very much.
Probably they can't hear.
Before we go to Mr. Townley, as I said, we'll go to a question in the queue from Alex Parkinson. Since identity becomes the criteria for enforcing trust domain membership, what was your experience of getting government certification authorities to accept this versus the old, comfortable, understood approach of domain boundaries enforced in network location?
It's a good question. It's a very long-winded answer, so I'll try and answer it succinctly, this one. So effectively, this was for a government department, or a ministry. So they bought into it themselves, and then we had to go and talk to the certification authorities to make sure that they were happy with the approach. And really, it wasn't outside the bounds of the New Zealand approach, because it was about strong authentication and strong authorization. And the minute we explained that in detail, they were happy with it.
That was succinct. Mr. Townley, are you on stage? Andrew?
He's dropped off. He said he couldn't hear anything.
Okay, let me see if I can get a different off-stage question for you then. Would you not say, sorry, this is from Peter Seedsma. Hello, Peter. Absolutely wonderful to hear from you.
Wow, it's all the usual crowd giving me jip.
Yeah. Would you not say that .1x is compromised to the idea of zero trust networking? It explicitly puts trust in the network.
I would, but go and have an argument with Google over that. That's their model, not mine. I haven't used that. I haven't used .1x at all in any of the models I've developed. So, but yeah, I tend to agree. It's explicitly a mechanism for trust in the network.
Okay, while we're waiting for Andrew to reconnect, it wouldn't be like Mr. Seedsma to start the argument with Google at all.
Actually, I think just to add to that point, though, I think Google's use of it, if I remember rightly, it's been a little while since I read their papers. Their use of it isn't about explicitly granting trust. It's about using it as another contextual mechanism to grant access to additional services. So if you're on the corporate network and you've 801.x authorized or authenticated the device, it allows additional services, but they still have to pass all the other authentication checks anyway that the external users would have to pass. It's just another mechanism to give them access to additional services that they want to tightly restrict where you can access from. But yeah, again, it kind of breaks the zero trust model in my opinion. But who am I to question Google?
Well, Peter Seedsman just posted, then we agree. So no special t-shirts from Peter this year. Another question in the queue, originally from Matt Dickey and commented by Shar Sample. Should we not be thinking higher up the stack, data-centric, etc., rather than network-centric? And Shar Sample said, yes.
Yes.
Nice and easy.
Yeah.
There we
I
go.
look forward to seeing the architecture he comes up with.
Matt Dickey, all in agreement in one word. That has never happened in the history of COSAC before, I don't think. Have we got Mr. Townley back online? No, we haven't. Okay. Another question from Matt Dickey. It's got a Greek character in it, Matt. In a service world, the network becomes flat, so it's all about TLS-MA, but how to manage the complexity and performance hit? Yeah, that's a conversation I've had this week or in the last week or so with a couple of colleagues of mine. The end-to-end encryption idea, and then the putting up the model where the traffic from the end user is basically encrypted until it hits a load balancer of some description, and then the load balancer feeds back clear text into the data center. And it's like, that's cool, but you're trusting the network there. The performance hit's always going to happen somewhere, right? It's a trade-off, and this is what I was saying earlier. It comes down to anything when you're modeling this out. It's the trade-off. Like, what trade-off do you want to take here? Is it the cost of being able to spin up more machines in your virtual data center or the cloud to handle the traffic loads that you're taking, but encrypt it? Or is it the fact that your traffic's in clear text? And there's no right or wrong answer. It comes down to what are you more sensitive about within your environment, money or the potential threat to the traffic being intercepted. And then obviously you overload into that the fact that most security network tools require you to decrypt your traffic so that it can be captured. And we're in an interesting world, right? Where the tools that we've created over the last 20 years actually ask us to decrease our security. Well, as always, everything comes back to a risk balance. So, Chris, you said you'd finished early, but we in fact have 1 minute left. So we'll leave the last question for Mr. Townley. Over to you, Andy.
Thanks. Sorry about the audio hiccups. So back to the second diagram you did after Google. So the one from the book where you were talking about, the segmented versions and having that segmentation piece. I mean, I guess when I was listening to it, because I was in your talk last year, but it occurred to me that, like, if we start building networks that way, doesn't then that become like the prime target for people to want to compromise? Because isn't that, or maybe I just don't understand the model because I haven't read the book.
I completely agree. I've read the book. I won't say that I understood every concept in it because it's very low level engineering from a network point of view. But I think you're right. The challenge with anything that requires control planes or the like is that's where you're going to attack, right? Because that's where your biggest what's the word I'm looking for? It's where your biggest success rate would be. If, like, rather than attack the individual systems and hope that you can get a small match to attack one service, but then not access anything else, is extremely resource intensive and win low. Whereas attacking the control plane could potentially give you access to everything in the environment. So in environments that use this model, or you will have to assume that the attack target would have to be the control plane.
Yeah, I mean, it's kind of like tapping the wiretap almost, where if it was really kind of like a virtual machine type of that's what sprung to mind conceptually, was if you've got an attack on the virtual machine environment, then you potentially can compromise anything on top of it. It was a similar thing here. And then the second part of my question was, I only heard about this yesterday. I was watching an Avangale Google talk on True Sona. He mentioned that the U.S. government had used it for secure communications with the CIA, and then they've made that publicly a public version of it. I was just curious if you knew anything about that or had figured out if that fit into this kind of model. Or
I haven't looked at it, to be honest with you. Yeah.
Because the thing was, they claim anyway that they could guarantee the identity of somebody sitting in Afghanistan for the FBI to send information back to the government, and so it seemed like it would be a similar kind of identity isolation and context-based thing, but I didn't know. So cool, thanks, great talk.
Thanks.
So time is up. Thank you very much indeed, Chris. There's a number of discussion points in the chat window, and from Andrew, and another question from Dimitri in the queue. Love you all to join the networking event and talk that through in more detail in an open forum. But for now, Chris, thank you very much as always. Great to have you. That's about 10 in a row that COSAC you haven't missed, so wonderful to have your input as always. Thank you very much. For everyone else, you will now see the display screen show speaker is getting ready, and we'll be with you back live in just a couple of minutes. Thanks very much indeed, Chris.
Thank you.